Welcome to or back to through Inquisitive Kids. In this video, we will be looking at the lesson Binary Linear Equations or Linear Equations in Two Variables and Linear Functions, their similarities, differences, and relationships. This is part 1 to our full lesson on binary linear equations and linear functions. There will be a follow-up for this lesson as to part 2, so be sure to subscribe so you'll get notified when we upload that video very soon. Learning goals. Understand the relationship between systems of binary linear equations and linear functions. Able to find approximate solutions to binary linear equations based on the graph of linear functions. Observe and think. If you were to categorize this equation x plus y is equal to 5 into one of the sets linear equations or binary linear equations, which category would it fit into? So would it fit here, the set where it says linear equations in two variables, or linear functions? The relationship between system solutions and corresponding coordinates of graphs. Question 1. How many solutions does x plus y is equal to 5 have? Write the ones you know. There's actually infinite. You might write this, such as x is equal to 0, x is equal to 5, x is equal to 2. But who says it has to be whole numbers or even, positive numbers? You could do negative decimals. You could do all sorts of stuff, so it doesn't really matter. So here, it would have infinite solutions. Converting x plus y is equal to 5 into a linear function in the form of y is equal to kx plus b would be, so you might also know this as mx plus b, where k and b are parameters and y and x are variables. X would be the slope and b would be the y-intercept. And that would be y is equal to negative x plus 5. We didn't change anything here, but all we did was isolate y onto one side. Question 3. Graph y is equal to negative x plus 5. So the Cartesian coordinate system is something I believe we have covered in Unit 3. And if you haven't looked at that yet, or you think you might need some review, be sure to go down into the description below this video, and I will be putting the link to that playlist, that unit, down there. So if you think you need extra review or revision or help, go down there quickly, because the rest of this lesson will be including lots of skills with Cartesian coordinate systems. Okay, yeah. So the things went on eventually going behind this table. This should be 5. So when x is equal to 0, this is 5, and when this is equal to 0, this would be 5. Challenge question number 1. Are all the solutions to x plus y is equal to 5 all plotted somewhere along the function of y is equal to negative x plus 5? And the answer is yes, all of the solutions are plotted. So any solution that satisfies x plus y is equal to 5, you can always find somewhere along this line. Challenge question number 2. Take any point along y is equal to negative x plus 5, and would it be a solution to x plus y is equal to 5? So this is a bit like the last question, except now it's sort of flipped. Would it be a solution? And yes, they still all satisfy x plus y is equal to 5, right? Because it was plotted based off of the condition that y has to be equal to negative x plus 5. Challenge number 3. Is the graph of all the points with the coordinates of the solution to the equation x plus y is equal to 5 the same as the graph of the linear function y is equal to negative x plus 5? And yes, they are equivalent. So what this is saying is that if you look at the coordinates of each of the points all dotted along this line. They all match the circumstance that x plus y is equal to 5. So those are your some very interesting facts and notices in things that you should be noticing right now. So really the solution to x plus y is equal to 5, they all exist on the graph of the linear function that y is equal to 5 minus x, or negative x plus 5. So the conclusion would be the solutions to the linear equations would have a one-to-one correspondence with the coordinates of the points on the graph of a linear equation. Practice. The graph of all the points with the coordinates of the solution to the equation 2x plus y is equal to 5 is the same as that of the linear function what? So it's asking you really to rewrite this equation given right here as a linear function in the form of y is equal to mx plus b or kx plus b. So after isolating y on one side, you would have y is equal to negative 2x plus 5. Out of the 4 lines shown in the figures, where the coordinates of each point on the straight line are the solution to the equation x minus 2y is equal to 2 is, so that would be C. Okay, solutions to systems of equations and the corresponding intersections of lines. So try. Solve x plus 5 is equal to y. X plus y is equal to 5. 2x minus y is equal to 1. So after eliminating the variables, we would get x is equal to 2, y is equal to 3. So a very simple, very decent, basic system of equations that you probably know how to solve. Please graph functions, and there's 2 functions, on the same Cartesian coordinate system, and then find out the coordinates of their intersection. Compare how they relate to the solutions of the above equations. So now it's taking the same equations as above, but just converting them into linear functions and then plotting those on the same Cartesian coordinate system. Okay, so we do that. And then we see that their intersection is x is equal to 2, y is equal to 3, which also is the solution to each of these 2 equations. So think, what does the solution of the system of equations have to do with the coordinates of the intersection of the graphs of these 2 functions? So the solution to this system of equation is x is equal to 2, y is equal to 3. It is also the coordinates of the intersection. Now let me explain why. Well, we know that all of the coordinates of the points on this first line here, y is equal to 2x minus 1, satisfy the equation 2x minus y is equal to negative 1. And the same for the second equation too. All of the coordinates of these points on this line satisfy its corresponding equation. So what is the one point that satisfies both this equation and this equation? Well, being straight lines, there is only one, and that is 2, 3. So it makes sense that it's the coordinates of the intersection, because that means it's the only point on this entire Cartesian coordinate system that will satisfy both of these 2 equations. Here's the conclusion. Determining the coordinates of this intersection of the 2 straight lines is equivalent to finding the solution of the corresponding system of equations. Solving a system of equations is equivalent to determining the coordinates of the intersection of the corresponding 2 straight lines. So again, the solution to a system of equations is the same as the coordinates of the intersection of the 2 linear functions. So here we're thinking in terms of algebra, and here we're thinking in terms of geometry. Okay, example 1. Solve x minus 2y is equal to negative 2, 2x minus y is equal to 2, using graphs. First step is to convert these into their linear functions. Graph, and then we have line 1 and line 2, and their intersection would be the solution. So this would be yet another way that you could use to solve your systems of equations. Therefore, the solution to the system of equations is x is equal to 2, y is equal to 2. Notice there's writing the solution in the proper format and to check if the answer is accurate. Let's do some practice. If the solution to x plus y is equal to 5, 2x plus y is equal to 8, is x is equal to 3, y is equal to 2. Therefore, the coordinates of the intersection between these two equations would be 3, 2, when x is equal to 3, y is equal to 2. Linear functions y is equal to 5 minus x and y is equal to 2x, negative 2x plus 8, have their intersection at 3, 2. Therefore, their solution would be x is equal to 3, y is equal to 2. Now we're at our final section of this lesson, which is relationships between systems of equations and parallel lines. In the same Cartesian coordinate system, what is the positional relationship between the graphs of the linear functions y is equal to x plus 1 and y is equal to x minus 2? Well, here we can graph. Can you plot this system of equations on a graph? How many solutions does it have? But we see that sometimes lines can be parallel, and what if they don't have any intersections? Well, what did you notice? Well, the two non-intersecting lines, L1 and L2, there's two non-intersecting lines. When they're parallel to each other, their slopes, which is K's, K1 and K2, is equal, and vice versa. When K1 and K2 are equal, the two lines are parallel. And when C1 does not equal C2, there is no solution to these two equations. So I just want to tell you something. This also if you think in basic logic, it makes sense. If you have x minus y is equal to negative 1, but in the same sense you say that this x minus 1 is also equal to 2, well, that doesn't make sense. It won't have any solutions then, because that's just talking gibberish. You can't have the same thing equal two different values. So that's why it has no intersection. Class summary. Learn about the relationships between binary linear equations and linear functions. So here this should say functions. We learn about the relationship between the solution to the system of equations and the graph of the linear equation. We learn about the relationship between the system of equations and two variables and their corresponding two intersecting straight lines. But we also learned that sometimes the two straight lines may not intersect and they might just be parallel. Yeah, so those are the three things that we mainly learned today. The first skill is to understand the relationship between systems of binary linear equations and linear functions. And the second skill is to find approximate solutions of binary linear equations based on the graph of linear functions. Thank you so much for watching through Inquisitive Kids today. Remember, if you liked our content, be sure to hit that like button. And remember, the part 2 to the same lesson is coming up soon. So if you would like to get notified when that comes out, be sure to also click that subscribe button. Thank you so much again for watching through Inquisitive Kids, and see you next time.